Okay, in this lesson we're going to talk about Venn diagrams. Venn diagrams are basically a two-way table, except it's two circles and not boxes. So if you look at this one, if I wanted to make this into a Venn diagram, let's say I'll do male and Democrat. I could do whatever I want here. But in this bubble, these are male Dems. There's 50 male Democrats. In this bubble, these are males, but not Democrats. Males, but not Democrats. There's 30 males that are not Democrats. And notice all the males, there's 80 of them. In this bubble, these are Democrat females, 65. In this bubble, they aren't male and they aren't Democrats. These are Republican females, so 70. All right, so on a Venn diagram, if this is A and B, this is A and B. This is not A and B. Basically this. Or, I'm sorry. This is A and not B. So A and not B, I could say that. This is in B, and it's not in A. And this is not in A, and it's not in B. So that's how you got to think about this stuff. All right, so let's go here. So here's Venn diagram, sports and band. How many students participated in sports? Well, 442 and 21. Because these are sport band people and these are sport people, but in the bubble of sports, 442 are standing on this side of the room, 21 kids are standing on that side of the room. So 442 plus 21, there's 463 athletes. How many students are in the band? Well, there's 21 in the band here. In this bubble, there's 31 here, so that's 52. How many students did not participate in organized sports? So they can't be in the sport bubble. So 31 and 339 did not play sports. So you gotta add these up. 339 plus 31 is 370. How many students participated in sports or played in the band? Well, the only one that didn't play sports or in the band are these people, but these played sports or in the band. So 442, 21, and 31. 494. How many students participated in neither sports nor band? That's 339. Okay, now, how many students are in, these are all the same picture. I don't know what they're doing here. Shade the parts of the Venn that represent it. We just did that. All right, how many, let's just look here at this picture because it's the same picture. How many students are in high school? Well, we just have to add all four of these up. So 442 plus 21 plus 31 plus 339. So looks like there's 833 total students in here. Suppose one student is selected at random. What's the probability that this student is involved in sports or band? So 442, 21, and 31 is 494. So 494 out of 833. For one randomly selected student, what's the probability the student does not participate in band? So they are not in band. 442 isn't in band, and 339 isn't in band. The 21 are in sports, but they're still in band because they're in that bubble. So if I add these up, I get 781 over 833 total people. What's the probability that one student participates in neither sports nor band? 339 over 833. Okay, let's go here. All right, so we got these two rules here. A and B is A times B. We already did that. But A and B could be A times B, given that A occurred. So just know if you see A and B, you're multiplying A and B. But B could change depending on if you put it back or not. And, well, you'll see what I mean by that. Okay, a person pulls a red marble out of a bag that has 5 blue and 7 red. So here, 1, 2, 3, 4, 5. And I have 7 red. 1, 2, 3, 4, 5, 6, 7. So a person pulls a marble out and does not put it back in. So once they get that marble out, there's only 6 marbles left. So that's going to change stuff. So that's actually sampling without replacement, without putting it back in, without replacing it. What's the probability of pulling a second red marble out? Wait, is the probability of pulling a second red marble out dependent on pulling the first one out? Yes, because the chance you pull out a red on the first time is 7 out of 8, 9, 10, 11, 12. The chance you pull out a red on the second time, see, a red one's missing. So I have 6 reds left. I have 6 ways to pick a red out of now 11 balls left. So these events are dependent because picking this one depends on the first pick that you had. All right, a person flips a coin and notes that it comes up heads. Then the person rolls a standard 6-sided die and notes it comes up a number less than 3. It's the probability the number came. These are independent because flipping a coin has nothing to do with rolling a die. It doesn't matter. You could flip 30 heads in a row, which means your coin might be a little rigged, which could be good because then if you start gambling with that coin, you know, you're going to start cleaning up. But rolling a die, it doesn't matter what this one was. So these are independent events. These are dependent events. All right, elementary class of 8 boys and 10 girls. A kid is chosen at random and it's a girl. A child is randomly chosen again from the remaining children. It's a boy. What's the probability of choosing the boy dependent on choosing a girl? All right, so the probability we get a girl on the first pick, well, there's 10 girls out of a total of 18 people. The probability we get a boy on the second pick, remaining children, so we didn't put the girl back in the bag. Of course, it'd have to be a really big bag to hold 18 kids, but, you know, it's possible. So there's still 8 boys, but there's only 17 people left. So that's it.